Hello everyone and welcome. In this video we're going to compute the following two integrals. A equals integral from 0 to pi of cosine of x plus cosine of x dx, and the second is b equals integral from 0 to 2 pi of sine of x plus sine of x dx. Now let me just say that it's really hard to use the fundamental theorem of calculus in order to compute these two integrals because we can't easily find antiderivatives for these two functions. So instead, we can use some symmetries that come with these functions. So let's get started. Now, I'm going to recall some properties of the cosine and the sine function. The first property is that the cosine of pi minus t is equal to negative cosine of t for all t in the set of reals. And this simply means that whenever we have two angles that add up to pi, their cosines are going to be opposite. The second property is the oddness of the sine function. That is, sine of negative t is equal to negative sine of t for all t in the set of reals. And the third property is the periodicity of the sine function. Sine of t plus 2 pi is equal to sine of t for all t in the set of reals. This simply means that the sine function is 2 pi periodic. Okay, now let's compute the first integral. Okay, so we're going to use a change of variable. We're going to say that t is equal to pi minus x, or equivalently that x is equal to pi minus t. Now, because we just made a change of variable, we're going to get some new limits of integration. So let's find them. Now, for x equals 0, t is equal to pi. And for x equals pi, t is equal to 0. Also, if we differentiate x with respect to t, we get negative 1. So dx is equal to negative dt. Now, let's compute the value of a. So let's recall that a is equal to integral from 0 to pi of cosine of x plus cosine of x dx. Now, I'm not just adding the two cosines. Now, one of the cosine is actually inside the other cosine. Okay, so this is equal to integral from pi to 0 of cosine of pi minus t plus cosine of pi minus t negative dt. Now, we're going to get rid of this negative in front of dt by simply changing the order of integration. So the upper limit is going to become the lower limit and vice versa. So we get that this is equal to integral from 0 to pi of cosine of pi minus t plus cosine of pi minus t dt. Okay, now we're going to use property P1. So cosine of pi minus t is equal to negative cosine of t. So we just replace it. And then we rewrite this a little bit differently. Let's rewrite the inside a little bit differently. We're going to factor negative 1. So we get that this is equal to integral from 0 to pi of cosine of pi minus parentheses t plus cosine of t, and then dt. Okay, now we want to use property P1 again. So we get that a is equal to integral from 0 to pi of negative cosine of t plus cosine of t dt. Yeah, so far so good. And finally, we use the fact that the integral is actually linear. So this is equal to negative integral from 0 to pi of cosine of t plus cosine of t dt. And this is exactly negative a, right? This is exactly negative a. So a is equal to negative a. And this is equivalent to saying that a is equal to 0. So the integral from 0 to pi of cosine of x plus cosine of x dx is equal to 0. Now let's move on to the second integral. Now here we're going to denote by f the function defined by f of x equals sine of x plus sine of x. And we're going to prove that this function is odd and it's 2 pi periodic. Okay, let's start with the oddness. So f of negative x is equal to sine of negative x plus sine of negative x. But we know that the sine function is odd. So I'm going to use the oddness on the first sign. So meaning that the sign inside the sine. Okay, so the first sine function is odd. Therefore, we get that this is equal to sine of negative x minus sine of x. And then we use the oddness on the second function, so the outside function. So this is equal to negative sine of x plus sine of x, which is exactly negative f of x. So f is odd. Now let's check that it's 2 pi periodic. So we want to compute f of x plus 2 pi. This is equal to sine of x plus 2 pi plus sine of x plus 2 pi. Now the inside function is a sine, it's periodic, and it's 2 pi periodic. So I'm using property P3. So this is equal to sine of x plus 2 pi plus sine of x. And then let's rewrite this a little bit differently. So this is equal to sine of x plus sine of x plus 2 pi. Now let's look at whatever is inside the parenthesis as t. And we know that sine of t plus 2 pi is equal to sine of t. Okay, so this is equal to sine of x plus sine of x, which is exactly f of x. So f is 2 pi periodic. Now I'm going to use the fact that this function is 2 pi periodic and odd in order to compute the value of b. So let's recall that b is equal to the integral from 0 to 2 pi of f of x dx. And f of x is the sine of x plus sine of x. Okay, now we know that this function is 2 pi periodic. Therefore, we can integrate it on any interval with length 2 pi. For instance, we can integrate it on the interval from negative pi to pi. Okay? And the reason is because the function is 2 pi periodic. Now, we have an odd function, and our interval is symmetric about 0, the origin. Therefore, the integral is 0. So b is also 0. And I think this is a good place to stop. Okay? See you next time.